What's good, everybody? Welcome to the very first video for grade 7. Today we will be discussing whole numbers as our first chapter, and within whole numbers we're going to look specifically at number systems. So just a recap with regards to whole numbers, which is our very first chapter, we saw that whole numbers represent positive integers, also including the number 0. And we saw that natural numbers refer to counting numbers. When you count something, you always start from counting from the number 1, 2. If I have 6 sweets, I'm not going to start 0 sweets and then 1 sweet. I'm going to start straight from 1 sweet, 2 sweets, 3 sweets, and so on. So actually, we saw natural numbers or counting numbers refer from counting from the number 1, whereas whole numbers represent all natural numbers, but including the number 0. So starting from 0 onwards. I hope that makes sense. Then specifically, we're going to be discussing number systems in this very first chapter. So you might be asking, what is a number system? That's really a good question. A number system, very simply, is just a system used to represent numbers, right? So actually, the way or the system in which numbers are represented can either be as a digit or it can be as a symbol, right, or letter. When we think of some examples of number systems, we can think about Roman numerals, right? We can also think about the Hindu Arabic number system, which is basically the decimal system. There are many different systems, even thinking about binary number systems that simply use the digits 0 and 1, So today we will be specifically focusing on Roman numerals. So we will be focusing on Roman numerals. Then what are Roman numerals? Roman numerals are simply a number system whereby certain letters are used to represent values, and there are very specific letters that are used, right? The Roman number system or Roman numerals simply represents numbers starting from 1 onwards. And of course, we will have to think about what are some of the letters or what are the letters that are actually used in order to represent values when we think about the Roman number system or Roman numerals. Then when we start off, we see that the letter I represents 1. And there's something important also to realize that when writing Roman numerals, it's different from how Roman numerals would appear typed out on maybe a test page. And that's basically more specifically for expressing the letter I. Then when we also think about Roman numerals, they can be written uppercase or lowercase. I'm just going to focus on writing them uppercase, just because it's easier to see visually. So I represents 1. Then the letter V represents the number 5. The letter X represents the number 10. The letter L represents the number 50. The letter C represents the number 100. The letter D represents the number 500. And the letter M represents the number 1000. So when we think about this as well, there are certain rules, if I can call them that, within Roman numerals. And the very first rule that I will put for us here, the very first rule is that, or rather, let me express how to read Roman numerals. So Roman numerals are read from left to right. So depending on how you arrange these different symbols together, or how you arrange these different letters together, it will express a particular value or represent a particular value. Say I want to express the number 3234. How I arrange these letters will depend, right, on the kind of number I'm trying to represent. There's many different ways to represent numbers, but how you arrange those letters next to each other, that will ultimately lead to a calculation of a specific result. So if you arrange them incorrectly, then you will lead to an incorrect number you wanted to represent. I hope that makes sense. So the very first rule goes as follows. If you have a symbol of a larger value next to a symbol of a smaller value, then the operation it would require is addition. You will have to add the value of those letters being discussed. So let me take us to our first example, which can make this a bit more clear. If I want to express the number 11, I already know, looking at this list, I can express it as 10 plus 1, which is x plus I, right? Then, of course, I would just write them together like that to express that value. Then I already know that from this list here, I know that x represents 10, I know that I represents 1, and the fact that they represents the rule 1, that this x is a symbol of a larger value, which is 10, next to a symbol of a smaller value, which is I, means I should do what? I should add the values of these symbols together, and that will give me what? It will give me 11 that I'm looking for, right? But then the second rule goes as follows. If I have a symbol of a smaller value next to a symbol of a larger value, then that would indicate the operation should be subtraction. So this is really important. So let's express this through a very simple example. Let's say I want to express the number 9. And I can express the number 9 as 10 minus 1, right? So when expressing this number, I would write it in this way, the I before the X. And why is that so? I know that I represents the number 1. I know that X represents the number 10. But according to my rule, when I read from left to right, like all Roman numerals should be read from left to right, as I'm reading from left to right, I notice that the symbol I has a smaller value, which is 1, then the symbol next to it, which is X, and has the value 10. Then that means that the operation that I use must be an operation of subtraction. However, this is really important. We saw that Roman numerals represent numbers starting from 1, right? Which is I. Meaning that actually there are no negative integers that can be expressed through Roman numerals. Meaning that I can't say 1 minus 10, right? I have to say 10 minus 1 because it must give me a positive integer. It must give me a positive value. So then how will I express that? I would express the value as, I'm going to try and write it like this so that makes sense. I would express the value as, in fact, 10 minus 1. I hope that's very clear and that makes sense to everyone, which will of course give me what? Yeah. It will give me the value 9. So that's really important. That's really, really important. So moving on from that example, what we also have to understand when thinking about Roman numerals is that the Roman numeral can have a bar. So certain symbols within Roman numerals, they can contain a bar above a symbol. And simply what this bar means is that whenever this bar appears above a symbol, it simply indicates that I must multiply by 1,000. So the bar represents a multiple of 1,000. So I'll give us some examples. Say you have 3 x's that are next to each other, right? And you place a bar above that. Then how can I understand this value? Well, I can understand this value like this. I know that this symbol here represents 10 and 10 and 10, right? This is what I know, right? Then, of course, back to my first rule, if I see, symbols of a larger value next to symbols of a smaller value, then it's addition. But this also means that if I have symbols of a larger value next to symbols of an equal value, right? So not just smaller, but it also includes symbols of a, and I'll just try and make this very bold and clear, of an equal value, right? Then I also use the operation addition. Then it would mean that I would need to add these together, right? So it's the same. So I'd express this as 10 plus 10 plus 10, right? However, within this, because the bar is above, then the second thing I would do is I would need to multiply by 1,000. So that's the order. Whatever is underneath the bar, whatever is underneath the bar is calculated first. Then, secondly, the bar above it is then applied second, right? And that's why we looked underneath the bar and we saw firstly that I must firstly add what's underneath the bar, 10 plus 10 plus 10, that gives me 30. And then secondly, I must multiply by the bar which is the second operation, which is multiplied by 1,000. And what value do I get in total? I get 30,000. What's also important to note is that there can be instances where a bar, right? There can be, sorry about that, there can be instances where you can get multiple bars above a particular symbol. So if we think about this, we can express it like so. So let's think about another example, and let's think about this example. Let's say I want to express this, right? How would I denote that? Or rather, let's make this, yes, let's make this like this. Then basically, how would I want to represent this? Then I would say, I would first look and calculate what's underneath first, underneath the bars. Then I would go to what is above the bars, second, and then I'd go to the last bar, third. That's our thought process. So, firstly, I would then look at what's in between the bars. Underneath the bars, it's 10 plus 1. Then I know I need to multiply by 1,000 because that's my first bar, right? That's my first bar. Then I know I need to now multiply by another 1,000 because that's my second bar. Then what would I get? I get 11 multiplied by 1,000 multiplied by 1,000. Thousand multiplied by 1,000. Sorry. Then in total, that would give me 11 million. And this is just an example, right, of how to think about the bar appearing above a symbol. Then secondly, or furthermore, we need to look at some basic or expressing Roman numerals from 1 to 10. And this is just the system that they use to express numbers from 1 to 10. So when expressing this, we can express it as follows. We saw the letter I represents 1. Then 2 I's written in this way would represent the number 2, and then 3 I's would represent the number 3. When expressing the number 4, it would be expressed as IV, which would be 5 minus 1, right? Would give me 4. Then, of course, it's a V would represent 5. If I wanted to write 6, I'd write it as 5 plus 1, VI. If I'd want to write 7, I'd write it as V and 2 I's. Then if I want to express the number 8, write it as V and 3 I's. And then if I wanted to express the number 9, I express it as IX. And if I wanted to express the number 10, express it as in this way. So what's really important to note is that at no point can there be 4 letter I's appearing next to each other. That's just the system that they use to express numbers, and that's really important. So please always remember not to place 4 I's next to one another, right? So I just put that. Do not place 4 letter i's next to each other. So that's really, really important. So moving on from that, let's think about how to express certain numbers, right? Let's think about how to express certain numbers. Say I wanted to express the number 23. Say I wanted to express the number 86. Say I wanted to express the number 99. Say I wanted to express the number 16. Then how would we do this? So there are many different ways to do it. But of course, we can always try and think of what is the simplest way to express this, right? Then when I think about this, I know 16 must be equal to 10 plus 6. 23 must be equal to 20 plus 3. 86 must be equal to 80 plus 6. And 99 must be equal to 90 plus 9. Then when I think about it like that, I know that 10 can be represented by x, and I know 6 can be represented by vi. Then what will my solution be? X, vi. 20 can be represented, let me just put this here. So 20 can be represented by 2 x's. 3 can be represented by 3 i's. So what would this be? X, and 3 i's. If I wanted to represent the number 80, so there's two ways we can actually express this. I can express this as 8 x's, right? I can represent this as 8 x's. And I can express this as vi, right? And I can have this so this would be correct. But if I wanted a simpler way to express this, then I could think about how can I break up 80 plus 6 in a simpler way according to what I have seen right here. Then I know that L is 50 and I know that C is 100. So if I thought about this, I could have chosen to represent 80 plus 6 as maybe 50 plus 30 plus 6, right? Which could give me, then it could give me, this is L, I know this would be 3 x's, and I know that this would be VI, right? So I could just express this as L, 3 x's, VI. Then if I wanted to express the number 99, I could express this as 90 plus 9, right? Or I could choose, so if I express it as 90 plus 9, I could have said that this could be, I could express this as 50 plus 40 plus 9, right? And of course, I could have written it as L, and then I have 4 x's, right, which would give me 90, and then I would have IV to give me 9. Sorry, not IV, IX, to give me 9. But there's a simpler way that I can write this. I can write 99 also as 100 minus 1. Then what did we see is 100? We saw 100 is C. And what did we see 1 is? 1 is I. Then when trying to express this, how can I express this? Looking back at the rule that we saw, if I want to express 100 minus 1, then I have to go back to the rule, right? Which says here, once again, looking at for a symbol of a smaller value next to a symbol of a larger value, I subtract the values of the two symbols from one another, right? With the biggest value minusing the smaller value because I want a positive integer in Roman numerals. Then I would express this as, you can ask yourself the question, it would be IC, right? Because I have a smaller value, a symbol of a smaller value next to a symbol of a larger value. Therefore, I must subtract the bigger value from the smaller value, and that can give me 99. So I'm sure we all like, okay, these are just single, double digits that I'm trying to represent. Let's get bigger, right? Or maybe you're asking yourself, what if I have letters that I need to convert to actual values? So we will look at these examples as well. So let's look at our very first example. And let's say I want to calculate the value xcx. What is that value? Then, of course, once again, I know that x represents 10, c represents 100, and then x represents 10. But I know I must read, right? I must read Roman numerals from left to right. Then I can see when I'm reading from left to right, I see that 10 is smaller than 100. Then that will lead me back to, again, rule 2. If a symbol of a smaller value is next to a symbol of a larger value, I subtract those two symbols, right? So how would that look like? It would mean that I would need to say 100 minus 10, right? And then I would add, because I know that whatever's, I know 100 minus 10 is 90, then I know that 90 is definitely a much bigger value than, 10, right? Then, of course, I need to add then. I need to add 10, and that would give me 100. So you would, of course, wouldn't use this to express. You could have just written the letter C. But the key point I'm making this example is so that we understand the process of how to calculate reading from left to right, so that it's easier and simpler to understand. Then when we look at our second example, let's say we have the value dxv. And how would I express that? Then when looking, I can tell that d represents 500, x represents 10, v represents 5. So back to our very first rule, if a symbol of a larger value is next to a symbol of a smaller value, or a symbol of equal value, then I must use addition. So I can simply just add all those values together, right? Just add them, 500, 10, 5, can add. And that will give me what? It will give me 515. Then let's make it bigger, right? So let's think about a much larger value this time, and let's think about having the letter D, M, X, X. and then VI. Then again, I know that D represents 500, M represents 1000, X represents 10, X represents 10, V represents 5, X represents 1. Then as I'm reading again, as I read from left to right, how can I visualize this? Let me first put my placeholders in place. Let's do it like this. I know I must have 500 there, I must have 1000, I must have 10, I must have 10, 5. Let me just try and write this more neatly. So I know I need the number 500, need the number 1000, I need the number 10, 10, 5, and the number 1. Then as I'm reading from left to right, I notice that 500 is much smaller than 1000. Then going back to my second rule, right? If I have a symbol of a smaller value next to a symbol of a larger value, I must subtract the two. Then, of course, 500 minus 1000 will give me negative 500. But we know in Roman numerals, we don't want negative integers. We want positive integers. Then, because of that, what will I need to do? I will need to subtract the larger value from the smaller value, right? Then that will give me what? It will give me 1000 minus 500. And then, of course, I know 1000 minus 500 is, of course, 500, and that value is much bigger than x, right? Then, therefore, what will I do? I will add, and then I know 10 is equal to 10, so I'll add. 10 is greater than 5, so I'll add. And then 5 is greater than 1, then I'll add. Then what does that give me in total? It would give me 500 plus 26, right? Which would give me basically give me 526. So moving on from that, maybe you're asking yourself, maybe I have a bigger value that I want to express. To express the number 2000, expressing the number 2596. Then very simply, firstly, we will need to break this down. I can break this into 2000 to 500 to 90 to 6. Then there's various ways in which I can express or write this, right? I can express 2000 as 2. I can express 2000 as 2 m's next to each other. Sorry about that. Express 2000 as, can express it as 2 m's next to each other, or I could express it as 2 i's and a bar, right? because that will mean 1 plus 1 is 2, then multiply by 1,000 is 2,000. I can express 500 as DL. I can express 90 as 9 x's. Or I can express it much more simpler than that. I can express it as 100 minus 90, which would of course be x and then c. Why? Because when I know there's a symbol of a smaller value, right? If I know that there's a symbol of a smaller value next to a symbol of a larger value, then I must subtract the larger value. I must subtract the smaller value from the larger value. Then, of course, I get this, right? Yes, I get this. Then, moving on from that, if I want to express the number 6, I can express it as VI, and yes. So together, we can just write them together, and this can be MM DL XC VI, right? Or I could choose to express this number as II, the bar over its head, II. Sorry about that. Express this as II, then DL, and x's, and then a VI. And that's how you could have expressed 2,596. Sorry. Or I could have expressed it as, or I could have expressed it as two I's, two I's in the bar, and then DL, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 x's and a VI. But the simplest way is always the best way. And that's how we could have expressed 2,596. Let's move to another example. Let's move to example 5. And let's say we are given M, L, D, C, X, C, L, then it's 3 I's, and we asked to calculate the value. Then very simply, you go back to all the symbols. I know that's 1,000, 1,000, 1,000. I know that's 50. I know that's 500. I know this is 100. I know this is 10. I know this is 100. I know this is 50. And I know this is 3. Then as I'm reading once again, as I'm reading from left to right, what do I recognize? I see that here L is smaller than D, right? Then this would be an operation of subtraction. I also see that when I look here, I see that x is smaller than c, right? Which would mean what? That's an operation of what? Subtraction. Then if I had to express this, I would express this as, and I'm going to put it simply now because I think we all understand. Because I have three m's together, I would have three m's, right? Which is 1,000. Then I need to add this to my red, which would be 500 minus 50. Then I need to add that to the C here, which is 100. Then I need to also add that to my XC that I'm seeing, which you can put in red, which would be 100 minus 10. Then I'd add this to L, which is 50, and 3. Then what would this give me in total? It would give me 3,000 plus 450 plus 100 plus 90 plus 53, which gives me 3,000, 3,450, 3,550, 60, 53, gives me 3,693. So of course, this was just an example in order to show us how these operations work. But of course, there's a much simpler way to express all of these values together, right? If I had to think about expressing this actual number, 3,693, how could I have expressed this? Then I could have expressed this rather as, okay, my three m's together. I know I need D for 500, C to give me 100, right, to make 600, and then 90, which we've seen quite a, and then 90, which we could have written as next C, and then simply 3 i's, right? And of course, we saw how we got there, right? When we broke it down. So once again, 3,693. If we break down this, then I can understand 3,000 to be 3 m's, and then 600 to would of course equal, let's make it simpler, this would be 1,000 plus 1,000 plus 1,000. This would be 500 plus 100. This can be written as 100 minus 10. And this can be written as just 1 plus 1 plus 1. Then if I had to write that out, I'd write it as this is 3. Sorry. Think about it like this. This would be M, M, M. This would be D. This would be C. This would be C. This would be X. And then, of course, this would be I. And if I have to write that out, write it like this. Because this is an operation of subtraction that appears when a letter of a smaller value is next to a letter of a larger value. I write it like that. These two I can write together because they're addition. And these I can write in this instance. And then if I add all of these together in the correct order, I end up with that. Then thank you so much, everyone, for watching this video. I hope it helped you, and I hope that it can help you also master Roman numerals. Please continue to watch as we go to our very next segment, which will be discussing the Hindu-Arabic number system, or more specifically, the decimal number system. Thank you.